Welcome to the next lecture. Welcome to the new chapter. Chapter 5, Polynomial and Rational Functions. Let's start our section with quadratic functions. In this section, you should be able to recognize the characteristics of a parabola, understand the graph of how the graph of parabola is related to the quadratic function, and determine the quadratic function's minimum or maximum value, and finally solve the problems involving quadratic functions minimum or maximum value. So let's start with the first topic, recognizing the characteristics of a parabola. So quadratic functions, the graph of a quadratic function is generally U-shaped, and that U-shaped curve in general is called as a parabola in geometry. So a parabola can be simply recognized by two main differences. One is the vertex. Vertex is the point where the graph turns from either increasing to decreasing or decreasing to increasing. So we also call that point the point of inflection. So where the graph changes its behavior or the curve changes its behavior. So that point is the vertex, and if the parabola opens upward, the vertex is the minimum value of the quadratic function. So if the parabola opens downward, the vertex becomes the maximum value of the function. Now, one another key factor is the axis of symmetry. The axis of symmetry is a vertical line that passes through the vertex. So the vertical line here that passes through the vertex, we call that the axis of symmetry. So these are the two main characteristics that you need to understand for the understanding of a graph. So let's try and determine this here. So next, the other two concepts are y-intercept and x-intercept. So x-intercept is the point on which the curve cuts the y-axis. So the points where it cuts the y-axis is called as the x-intercept. The point where it cuts the y-axis is called as the y-intercept. So whichever line it cuts, we call it that intercept. If it cuts the x-axis, we call that x-intercept. If it cuts the y-axis, we call that a y-intercept. So how to determine the vertex here? So remember, the vertex here is the point of inflection. So this is the point. So this is the vertex. So that point is the vertex here. Next, you have to draw the axis of symmetry. Axis of symmetry is the vertical line that passes through the vertex. So here, this is the line that passes through the vertex, and we can call that the axis of symmetry. Next, we want to find the zeros. Zeros in general are also called as the x-intercepts. So the line where it cuts the x-axis is called as the zeros of the polynomial or zeros of the quadratic function. So here it cuts 1 and -3. So the zeros are 1, -3. Next, we want to find the y-intercept. So where does it cut the y-axis? It cuts the y-axis at this point here. So this is the y-intercept. So these are all the things that we have to find. So these are all the points that we can find for a given parabola. Now, let's try and understand the forms of quadratic functions. A quadratic function is a polynomial function of degree 2. So the graph of a quadratic function is a parabola, which we just saw, and the general form of a quadratic function is given by the equation f of x equals ax square plus bx plus c. So where a, b and c are the real numbers and a is not equal to 0. Next, the standard form of the quadratic equation is given by the function f of x equals a times x minus h square plus k. So here h and k represent the vertex coordinates. So the vertex h comma k represents the vertex, and a here is the coefficient, which generally is not equal to 0. So how do you find h comma k based on the standard function? So for example, let's say if I have f of x equals ax square plus bx plus c. From this, how do I find h comma k? H here is given by the formula minus b by 2a. K here is given by the formula f of h. so which is basically f of minus b by 2a. So this is how we can find h comma k from the general form of the quadratic equation. So let's try and understand how the graphs of parabola are related to the quadratic functions. So once they have given a quadratic function, we have to write the equation of the function in the general form. So to write that, first we identify the horizontal shift of the parabola, which is the h value, and we identify the vertical shift, which is the k value. And finally, we'll substitute the values, horizontal and vertical shift onto the h comma k in the function f of x equals a times x minus h square plus k. Next, substitute the values of any point other than the vertex on the graph of the parabola x and f of x, and you can solve for the stretch factor a value. And finally, we'll expand and simplify to write it in its general form. So let's try and use this formula here. So first thing we need to find is the x coordinate and y coordinate for the vertex. So this here is the vertex. So when you draw a horizontal line, you have the y coordinate. When you draw a vertical line, you have the x coordinate. So the h value is the one on the x-axis. The k value is the one on the y-axis. So h here is -2 and k here is -3. So from this we can write the equation f of x equals, so a times x minus h whole square plus k. So a times x minus h is minus of -2 square plus k is -3. So which can be written as a times x plus 2 square minus 3. So this is f of x. We need to find a now. To find a, take any point on the curve that you actually can find easily. So that point is here. So this point is easy to write down. So it is -1 comma -4. Sorry, -4 comma -1. So substitute. So here we are basically using the point x comma f of x, which is -1 comma -4. I'm sorry, which is -4 comma -1. Substitute this point into this function now. So f of x is -1 equals a here, a times x is -4, so -4 plus 2 square minus 3. So -1 equals a times -2 square minus 3. -1 equals a times 4 minus 3. So 4a minus 3 equals -1. 4a equals -1 plus 3. So 4a becomes equal to 2 and a becomes equal to 2 by 4, so which is 1 by 2. So now we have the value for a 1 by 2 h. So substitute it into the formula f of x equals, so substitute it into this formula here, a times x plus 2 square. So a is 1 by 2 times x plus 2 square minus 3. So you can further simplify the equation and you can expand it and write it down as well. For example, we can write it as x plus 2 whole square can be split into x square plus 2 times x plus 2 square minus 3. So 1 by 2 times x square plus 4x plus 4 minus 3. So which can be written as x square by 2 plus 4x by 2 plus 4 by 2 minus 3. So 2 ones, 2 twos, 2 ones, 2 twos. So it becomes x square by 2 plus 2x minus 1. So this is the function in its general form. So this is how you can write the quadratic function in its general form. Next, understanding how the graphs of the parabola are related to the quadratic functions. So let's say they have given us a function in the general form. How do you find out the vertex of the parabola? So whenever they give you first the equation in the general form, identify a, b and c and find h value from the coordinate system h equal to -b by 2a, and for k value substitute the h value into the equation and find the k value. So let's try a problem. So here they have given us a problem. So f of x equals 3x square minus 5x minus 1. So from that, if you compare it to a, b and c, so a is 3, b is -5 and c is -1. So from this we have h first, which is -b by 2a. so which becomes negative of negative 5 by 2 times 3, so which becomes 5 by 6. So k becomes f of h. So f of h is 3h square minus 5h minus 1. Substitute the h value here. So 3 times 5 by 6 square minus 5 times 5 by 6 minus 1. So 3 times 25 by 36 minus 25 by 6 minus 1. So if you calculate the value and take an LCM, so the LCM is 36. You have 3 times 25 minus 6 times 25 minus 36. So which becomes, so 3 minus 6 can be written as negative 3. So which becomes negative 3 times 125 is 375 minus 36 by 36. So you have negative 411 by 36. So this is the k value. So you have the k value and you have the x value now. So use the principles now. You have the h value, which is 5 by 6, and you have the k value, and you have the a value already. So write down its standard form. So the formula is f of x equals a times x minus h square plus k. So a here, the value is 3. So 3 times x minus h is 5 by 6 square minus 411 by 36. So this is the function f of x. So this is how you can write general form into its standard form. So use the same principle now and try to write the general form of this equation, standard form of this equation. So pause the video right here and try to solve this problem. Next, let's talk about domain and range of a quadratic function. So for a quadratic function, the domain is always from negative infinity to infinity. So the range is the one that changes. So range depends on the equation by itself. So if the parabola, if the graph opens upward, then the range can be written as k comma infinity so range is k comma infinity. So if it opens downward, then the range can be written as negative infinity comma k. So if you already know the k formula is f of minus b by 2a comma infinity, and here it becomes negative infinity comma f of minus b by 2a. So these are the equations for domain and range for quadratic functions. So how do you know if it opens up or opens downward? Is depends on the a value. If a is less than 0, if a is greater than 0, we can think that it opens upward. If a is less than 0, it opens downward. So this is how we can determine range based on the a value. So let's try and use this principle now. So you have the equation. So from this, so compare it with ax square plus bx plus c. So we get a, b, c. A is negative 1, b is 4, and c is 3. So we know that a here is less than 0. So the domain stays the same, which is from negative infinity comma infinity. Now range is what changes here. So range, we know that a is less than 0. Then the range is, it opens down. So from that we can say that if it opens down, so from negative infinity comma k. So how do you find k here? So which is written as negative infinity comma f of minus b by 2a. So let's find f of negative b by 2a. So which is f of negative b is negative 4 by 2 times negative 1, which becomes f of negative 4 by negative 2. So it becomes f of 2. So substitute 2 into the formula, you get minus 2 square plus 4 times negative 2 plus 3. I'm sorry, negative and 2 square and 4 times 2 plus 3. So negative 4 plus 8 plus 3. So which becomes 4 plus 3, which is 7. So from this we can write that this value becomes negative infinity comma 7 closed interval. So for this equation, the domain is negative infinity comma infinity and the range is negative infinity comma 7 closed interval. So this is how you can write the domain at range when you have a given function in its form. So use the same principle, pause the video right here and try to solve this problem and find its domain and range. Next, let's try and determine the minimum and maximum values. So if a graph opens up, then the value only has a minimum value. So when a graph, if the quadratic function opens up, so there will be a minimum but no maximum. If a graph opens down, there will be a maximum but no minimum. So remember this principle here. So how do you find out the maximum and minimum value? So the maximum value and minimum value can be found directly from calculating the vertex. So if a graph opens up, the minimum value is the value k. For a graph that opens down, the maximum value is also k. So the k value itself becomes the maximum value or the minimum value. So this is how we can find the maximum. Next, let's talk about finding the x and y intercepts of a quadratic function. So the line where it cuts the y-axis, we can call that the y-intercept. The line where it cuts the x-axis, we can call that the x-intercept. So for the graph here, it will never cut the x-axis. So this is a graph that does not have x-intercept. Here, this is a graph that will only have one x-intercept because there is only one point where it grazes. And this is a graph where it shows you have two x-intercept because it cuts at two different points on the x-axis. Now, so they have given us the question here. So they're asking us to find the y-intercept and the x-intercept. So to find the y-intercept, remember to substitute x equal to 0. If you want to find x-intercept, put f of x equal to 0. So let's start with the x-intercept first, or sorry, let's start with the y-intercept first. So we have to put x equal to 0, so which is basically f of 0. So f of 0 is 0 square minus 5 times 0 plus 6. So which becomes 6. So 6 here represents the y-intercept. Now how do you find the x-intercept? Put f of x equal to 0. So when you put f of x equal to 0, it becomes x square minus 5x plus 6 equals 0. Now solve this quadratic equation. Basically it becomes a quadratic equation. So solve this equation. So which becomes minus 2x minus 3x plus 6 equals 0. So x times x minus 2 minus 3 times x minus 2 equals 0. So you get x minus 2 times x minus 3 equals 0. So x becomes equal to 2, x becomes equal to 3. So these two here represent the x-intercept. So this has two x-intercepts. So this is how we can solve the question. So use the same principles now. Pause the video right here and try to find the x-intercept and y-intercept for this equation. So use the same principle again. So pause the video right here and try to solve this problem. So next, let's talk about graphing the quadratic equations. So how do you graph quadratic equations? For this, first, remember that we need the vertex. We need the axis of symmetry. and we need the a value, so which is also called as the stretch factor. Next, we also need 2 points on either side of the axis of symmetry. So we need at least 2 points on the either side of the axis of symmetry. So these are the only choice, and only then can we draw the quadratic function. So let's start with the vertex. So from the equation we have a equal to 1, b equal to -6 and c equal to 3. So vertex is h, which is minus b by 2a, so which is minus of -6 by 2 times 1 becomes 6 by 2, which is 3. K becomes f of h, which is h square minus 6h plus 3. So substitute the h value, we get 3 square minus 6 times 3 plus 3, so which becomes 9 minus 18 plus 3, so which is minus 9 plus 3, which becomes minus 6. So we have h comma k, which is 3 comma -6. So if you take a look at this graph, so you have 1, 2, 3, 5, 6, -1, -2, -3, -4, -6. You have 1, 2, 4, 5, 6, -2, -3, -4, -5, -6. So the center point is 0. So I'm going to try and write 0. So you already know the 0 point there. Now, so notate the point h comma k here. So on the x-axis it's 3 and the y-axis it's -6. So on the x-axis it's 3, on the y-axis it's -6. So this is the point here. Now, so for the next thing, draw the axis of symmetry. So axis of symmetry is the vertical line that passes through the vertex. So this is the axis of symmetry, and this is the vertex point. Now we have both the vertex and the axis of symmetry. Next thing we want to do is we want to find the stretch factor. The stretch factor is 1, so there is no change in the value. So we need 2 values to draw on either sides of the angle. So what can you do here is substitute x equal to 2 and x equal to 1 and find out the f of x value. In the same way, this side substitute x equal to 4 and x equal to 5 and find out the f of x value. Right, so how can we do that here? So substitute x equal to in this equation now. So substitute x equal to 1. So when you substitute x equal to 1, what do you get from here? So we had 1 square minus 6 times 1 plus 3. So 1 minus 6 plus 3, so which is 4 minus 6, which is -2. So for x equal to 1, the value is -2. So this is 1 point. Next point is x equal to 2. So which is going to be 2 square minus 6 times 2 plus 3. So which is 4 minus 12 plus 3. So 4 plus 3 is 7. So 7 minus 12 is -5. So for 2 it's -5. Next, for 4, substitute 4. So x equal to 4. We get 4 square minus 6 times 4 plus 3. So which is 16 minus 24 plus 3. So 16 plus 3 is 19 minus 24, which is going to be -5. So -5. In the same way, you can write x equal to 5, so which becomes 4 square minus 6 times, 5 square minus 6 times 5 plus 3, so which is 25 minus 30 plus 3. So 25 plus 3 is 28, minus 30 is, so plus 3 becomes -2. So which is going to be -2. So the easy way to know this is once you find the points on one side, equidistantly you will have the same point on the other side. For example, if it is 1 unit away from the axis here, this is also going to be 1 unit away. Here it is 2 units away, here also it will be 2 units away. So this is how you can draw the axis parts. So what you can do now is draw a curved line passing through those points. So this here is the curve for f of x equal to x square minus 6x plus 3. So this is how you can draw a quadratic equations. curve. So use the same principles now and draw this one. So remember that how do you decide whether it is opens up or opens down is based on the a value. Notice that a is greater than here 0, so which means that it is opens up. Here in the second problem we have -2, so which means that it is opening down. So use the same principle and try to draw the curve for this graph here. Next, let's try and use the x and y intercept to apply the quadratic function application. So you have a ball that's thrown upward from the top of a building, and the ball's height above the ground can be modeled as h of t equals -4.9 t square plus 24t plus 8. So when does the ball reach maximum height? So if you take this curve here, so what does that basically look like is it looks somewhat like this here. So we want to know what time it reaches the maximum value. So we are basically looking for the maximum value of the function. So what will be the maximum value of the function? So that value here, we are finding that value for t value. So we want to find the t value at that maximum value. So first thing that we want to do here is basically take the equation. So the equation becomes h of t equals -4.9 t square plus 24t plus 8. So we have h of t equals -4.9 t square plus 24t plus 8. So always find h comma k first. H comma k is, so we have to find h comma k. So h becomes -b by 2a. So a here is -4.9, b here is 24, and c here is 8. So -b by 2a becomes -24 by 2 times -4.9. So it becomes -24 by -9.8. So negative gone. So 24 by 9.8 becomes 2.45. So this is the h value. Notice that this is a graph of t and h of t. So which basically means that the h value that you found is the exact time for that one. So we are basically finding k here. So k here becomes f of h, which is -4.9 h square plus 24h plus 8. So which is -4.9 times 2.45 square plus 24 times 2.45 plus 8. So 2.45 square is 6.0025 times 4.9. So the k value here can be written as, so -29.41 plus 24 times 2.45, that is 58.8 plus 8. So you have -20, so 58.8 plus 8 minus 29.41. So the total value becomes 37.39. So the coordinate that you found here is t comma h of t. So the time at which it reaches the maximum height, this is seconds, and this value that you found is in meters. So the second answer is this one, 37.39 meters, and time is this one that you found. Now the next one is, when does the ball hit the ground, is the one that they're asking next. So for that we need to know the end point here. So the end point is, we are basically finding the x-intercepts. So basically take the equation. You have -4.9 t square plus 24t plus 8 equals 0. So we are finding the x-intercept. So x-intercept, oh I'm sorry, so we are finding the x-intercept. So this becomes, we can't solve this directly, so use the quadratic equation, quadratic formula. So a is -4.9, b is 24, and c is 20, so c is 8. You have x equals -b plus or minus square root of b square minus 4ac by 2a. So -24 plus or minus square root of 24 square minus 4 times negative 4.9 times 8 by 2 times negative 4.9. So it becomes negative 24 plus or minus root 24 square is 570. So 24 so is 576 plus negative into negative becomes plus 4 times 4.9 times 8 becomes 156.8 by negative 9.8. You have 576 plus 156.8 and take the square root of that value. So it becomes negative 24 plus or minus 27.07 by negative 9.8. So we can split this into two values. So negative 24 negative 24 minus 27.07 by negative 9.8, and the other one is x equals negative 24 plus 27.07 by negative 9.8. So the x value here represents time, so let's replace it with time here. So time here it becomes, if you look at the second value, we have 27.07 minus 24, so it becomes negative 3.07 by 9.8. Notice that time is never negative, so this is wrong. So choose this one now. You have negative 24, negative, so 24 plus 27.07 divided by 9.8. So the time becomes 5.211 seconds. So this is the time at which the ball reaches the ground. So the reason why we didn't take the negative value is because time is never negative. So we always take the one that is positive. So this is the time here. So this is how you can solve the problem. So use the same principles now, what we did in the last problem, apply to this. So solve the problem, pause the video right here and try to solve this problem.